Want to crack interviews at Mang and other top-tier tech companies? You can. With USA's #1 tech interview prep platform, you get access to 500 Mang Plus experts, all from the world's leading tech giants. We've already helped 25,000 plus tech professionals land their dream roles. You could be next. Don't miss out. Register now for our free webinar and take the first step toward your Mang dream.
Hey, how's it going, hitesh?
I'm good. How are you? Good
Doing
evening.
well.
Good evening.
Thank you. Yeah, sorry about yesterday, the
No
miscommunication.
worries. No worries.
It did get scheduled correctly today on my schedule, so I came a little bit more prepared. So
So you are based out of Bay Area, right? San Francisco.
yeah, I am in the San Francisco Bay Area. That's right. Yeah, I'm in a small town called San Ramon. I'm not sure if you're familiar with the area. It's about an hour away from San Francisco.
Mm-hmm.
Yeah.
And
How about
you are working for Google, right?
I am, yes. I work for Google at the moment.
Which group means which business line, like Google Cloud or?
Yeah, so I originally started in Google Cloud, and then I switched teams about 4 years ago into a PA called Platforms and Devices. At the time, it was called Platforms and Experiences, but two larger product areas merged, and it's called Platforms and Devices now. And so I work on the Fuchsia operating system. I don't know if you're familiar with Fuchsia, but it's a operating system developed in-house in Google, microkernel versus a macrokernel like Linux. And it's a capability-based operating system. So you declare, like, in Linux, you try something and the operating system catches you that you're doing something wrong. That's where a lot of the bugs come from.
Okay.
Forgot to catch the process doing something wrong.
So is it a new product? It is getting.
It's deployed right now. It's running on the Nest devices, like the little home hubs. Yeah.
Okay.
So yeah, how about you? Where are you based?
I'm based out of like Mumbai, India.
Okay, great, nice. I was born there. And so you are you're interviewing for Google in Mumbai?
Google, no, it's for Bangalore.
Oh, in Bangalore. Okay, so you'll have to like relocate.
Yeah.
Okay. And when is the interview?
It's tomorrow.
Oh, okay. All right, let's do this then.
I think I'm done with all other process. It's just like last round pending.
Okay.
Just go to the rest of like management and system design. Everything has been done.
Okay.
And you are operating at which level? L6?
I'm in L5.
L5.
Yeah.
Okay.
Yeah.
So how is L6 level? Is okay?
Yeah, it's fine. I interview L6 all the time.
Okay. No, in terms of like career progression means I'm just asking like L6 is a respectable position.
Absolutely.
Okay.
I think the job description really changes between L5 and L6, right? Like L3, you're still learning. L4, you've mastered your tools and your methods. Now you kind of have independence. L5, now you have leadership. And L6 is where you kind of start leading a little bit more. Like L5 has a little bit of leadership, a little bit of IC work, right?
Take leadership. L5 right?
Yeah, and L6
is more mixed tech plus people.
Yeah, you can choose to do the management, the people management as well, or you can just be an IC L6, in which case you are focused more on the technical direction. So now you're trying to influence the team, and then maybe you're kind of dabbling a little bit in some influence in other teams as well. And I guess it just really depends on where you want to land in the ladder, right? Like what you enjoy doing, because I think L6 is definitely respectable, right? It's just it's a different job a little bit than an L5, whereas the L3, L4, L5, those are they are pretty much like the same job, but just more
Got it,
independent.
got it. And L6 is like kind of like a level above, right? Which is heading towards like the next path, be it management
Yeah,
or be it IC, right?
it's like the responsibilities look very different in
Very
L6
different. Yeah,
compared
yeah,
to
yeah.
L5. Whereas if you go from L4 to L5, the responsibilities aren't really all that different. It's just maybe a little bit more independent.
Almost same, but little bit extra expectation, right?
Yeah, a little just
Mm.
like more independence. Where
Mm. What
now
about
some of these
L7?
L5,
L7 is more senior, right?
L7, yeah, that's more. So now you're leading like a group,
Mm.
and you have maybe multiple teams under you working towards some like,
Mm-hmm.
common goal.
Okay.
Yeah.
Okay.
All right. So should we do
All
this?
right. Yeah, yeah,
Get
yeah.
started?
Thank you. Yeah,
Yeah,
thanks.
absolutely. So they had a coder pad link yesterday, and it doesn't seem like they have that today. So let me see if I can. Hmm, see.
If you can share on like uh, some Google Doc, that also fine.
Yeah, yeah. Let's do that. Okay, that's a good idea. It's not gonna be like syntax highlighted or anything like that. So maybe you know what I can do. Or let's just do Google Doc. It's fine. It's not gonna be
Yeah,
syntax
yeah.
highlighted. But or actually, I can make it syntax highlighted. Let's see. Give me 1 second.
Actually, it is going to happen on Google Doc only. So.
Oh, okay. So that's actually
Mm,
better.
mm,
Because
mm, mm.
chat here. Can you see this?
Yeah, let me open that. Yeah, it's coming up. Tab 1. Yeah. Okay.
Yeah.
Yeah.
All right. So let's rename this tab 1 as bad
No,
code.
that's fine. That's fine.
Yeah,
Just,
because we're gonna do multiple.
yeah.
All right. So okay. So let's see if I can.
Where is that?
I can't insert code blocks in here. Building blocks. Okay. I guess in the internal Google Docs, you can insert code blocks, but I can't do that here.
Yeah.
Okay, whatever. That's fine. In that case, we'll just do something like this. So let me give you the problem description. Here's some bad code that we know, and we'll make it better, and then get to some better code, and then some of the best code, right?
Yep. Yep.
So the problem is called, I'm going to put that in a different tab, the problem description. The problem is called duplicate usernames, right? So if you go to the first tab, problem description, you can read about it.
Duplicate username. Okay.
Yeah. So this is just so that you know what the code is trying to solve.
Okay. So let me just read out. Yeah.
Mhm.
Okay. So it is basically the one person having multiple accounts, but we have to like not entertain that. We should
Mhm.
count only the one person as one particular individual, right? One account. Maybe different account, but we have to think like
Yes.
it should not be a fraud kind of things, right?
Yeah,
Uh,
exactly. Right. So you want to get the an accurate user count.
Accurate
But
user count.
you have a situation where you have people with multiple accounts. But
Mm-hmm.
like I think what's important is that this person one definitely has multiple accounts, right? But we've also found person two to have multiple accounts, except that person two has the same account as
Person one.
person one, right? So what that means is that this account, as well as all these accounts, are the same person, right? Because they,
Mm.
through this pose candor, whatever that is, Fum Con and Sointi Fifth are the same person, like through the transitive property, right? Because person one and person two have the same pose candor account.
So they are basically the same person we can consider,
Yeah,
right? Is that right?
exactly. Yeah,
Yeah, okay,
that's right.
okay, okay.
Yeah, that's what
Because
the
because they have same account, so we can consider person one and person two as same, and we can count only one, right? In that case.
exactly, yes. Yeah. So
Okay.
that's the problem description. And then if we go to the bad code tab, this
Mm.
code attempts to solve that
This
problem.
problem, this problem statement, yeah. Okay.
Yes, exactly. Right. So I think where we can start is, take a look at the code and then, tell me the general approach, right? Like the algorithm that they are trying to
Okay.
use.
Okay. Okay.
And then we can talk a little bit about, like, whether they implemented it correctly, and what, comments you would give on a code review.
Okay. Okay. Let me go back to bad code tab. I'm just going through code first, and then we'll
Yeah.
come back to, yeah.
Yeah.
So here hash map of key and hash set as a value list of like strings. Okay. What is G? I think G is users you are referring. The name of hash map.
Yeah. It's just some variable name that they have given.
Okay. I think we should have that correct naming convention instead of G.
Yeah, I agree. I need all of the things that you like suggest to them. Maybe what you can do is insert a comment, like, just this is what I would write.
Okay. Something like this, right? Here. I think I don't have writable access here.
Oh, you don't? Okay. Uh,
Request edit access. Let me request that.
okay. Actually, I just updated it. My bad. Sorry. You can just refresh. You should be able to edit now.
Okay. Yeah. So here, if I go in the do the things method, right? Static do the things.
Mhm.
First of all, why we need this as a static? Because it is in the class. If you want to reuse this method, you can have some
Mhm.
different utility class, right? Instead of having this static method, because
Mhm.
static things are not easily easy to test.
Mhm. So
So
maybe I'll write down what you're saying.
yeah, sorry.
I'll write down your notes so that you can
Yeah,
just
yeah, yeah, yeah.
when saying things.
Okay, and then for this null check and is empty check, we can use some utilities that is out of the box available, like Gova utilities like preconditions, or uh, some other collections utility like they have already available out of the box. Collections dot is empty,
Mhm.
that kind of utilities, right? Instead of having this raw logic.
Mhm.
Okay. Then coming to the variable name G, it should have been some logical readable name, like if it is basically the user account list, something like that, right? Yeah. Going down, users dot size. So here in this for loop, the users is I'm referring that hash map, right? Is that correct? You are
Yeah,
referring the
in
size,
the yeah, in the comment, and that's the one that's coming in from the parameter. It's a list, not G.
not G. Yeah. Okay. Okay. This is method. It is inside method. This for loop.
Yeah,
Okay. So that is parameter, I assume, right? Users
yeah.
is
Mhm.
okay.
Yeah, it comes from the parameter.
Users dot get I. So user group will have that. User group is basically you're grouping the user. Something like person one and person two will have like 6 account, but out of that one is duplicate. So
Hmm.
we'll consider that as a one user. So we are basically referring that as a user group to identify
Hmm.
that.
Right.
Okay. So user group is our actually basically the count of actual users.
For that one particular group, right? It's all the groups together is the count of the actual groups.
All the group, yeah, yeah, exactly, right. So the group is basically like, uh, okay, so let me understand that, right? The group concept. So
Hmm.
user one and user two, they are actually one user only, right? But we are to identify uniqueness, we are adding one abstract layer which is user group, correct?
Yeah.
And that user one and user two will be part of user group, let's say A, and that user group will have multiple such cases. So let's say user group A will have three persons which is having the same account. So in that user group, we'll count that person as only one, right? And
Yeah.
is the user group will have multiple users, or it will be just like will have like only one user group to user is only one to one mapping kind of.
Uh,
You're
well,
getting
let's
my
see what the
point?
code does. Yeah, yeah, I do, but let's see what the code does.
Okay, okay, okay.
Like I think you're trying to defend the code.
No, no, I'm
With
not trying to define. I'm
Yeah,
just
yeah,
trying to
yeah,
understand like
right.
the logically basically. I'm just thinking logically. But yeah, let's go to the code. Not empty. User group not empty. Then group dot get zero first user. Continue. Okay. Okay. We'll go to main method later. Yeah.
Yeah,
I think main method is basically the client which is calling your logic.
yeah. And that's not so important. I think what's more important is
Mm.
the
Yeah,
actual
yeah, yeah,
the
yeah,
main
yeah,
class.
yeah.
I think let's focus on what based on your
Algorithm.
reading of the code. Yeah,
Algorithm.
what algorithm are they
Okay,
trying
okay, okay,
to
okay, okay.
use? Imagine like you gave your report like go build this. They come back a few days later. They put this up for review, and you have to review
Hmm,
it.
hmm, hmm, hmm,
So
hmm.
you have to figure out like is this even a performant algorithm? Like all of the comments about code, that's definitely uh, good. That's correct. But the code comes after. Like if they have selected a bad algorithm, then they're gonna have to rewrite a lot of code anyway. So
So
it
I'm
might be a waste
thinking,
of time.
so for us, this one for loop, right, which is basically uh, iterating over the users list and
Mhm.
creating the user means basically user group, right? Means user dot get I, and then it is taking the list of user group, and from that it is taking the first user, right?
Yeah,
User group is not empty, then first user, and then continue. So and the below for loop is basic. So will this for loops in two different methods, or I can consider in the same method? They're
it's all in the
just
same method.
same method. Okay.
Yeah, it's all in the same method.
User group. Okay. So first for loop is just doing it will uh,
I
just
think
checking the first user. Okay. Mm.
here I'll from the problem description
Until
I'll add some.
not empty. Continue. Continue. Continue.
I'll delete this later, but so here, if in person one, this is one user group,
Mm-hmm.
right? It's highlighted as one user group, and then in person two, that's one user group,
Yeah.
right?
Okay.
So here for all of the different users, like in this users list, you get a list of all the user groups. So you get the first user group, and you go through all of the different. Well, you get the first user, but then you go through
First
all of the
user.
other users in that user group, and then you
Mm-hmm.
use this G, which is the global, I guess, maybe that's why it's called G, the global map that spans all the user groups.
Mm-hmm. You are iterating means basically first you find the user group, and from that user group find the first user. That's it, right? In the first for loop.
Mhm.
Users dot size. Okay. So first person one and person two, like if I consider that, so person one is first user means user group, person two is another user group, something of that
Yeah,
sort, right?
yeah,
Okay, okay,
yeah.
okay, okay. And person one and person two, person three are all are users. So that is where our users dot size, basically user list. And from that user, you are taking the user group,
Hmm.
and from that user group, you are taking the first user. Okay, okay, got it.
Right.
User dot size, user groups. So one person can have multiple user group as well, right? No, no, no.
Yeah, I mean, technically, yeah, because
Yeah.
that's
Okay,
what you have to
okay,
figure
okay,
out.
okay. Yeah,
That's what you're, yeah.
user group dot size, get user one. Okay. G dot G is our the global map. It contains U1, which is group one, not contains. Okay. It is not contains, then it will put.
Mhm.
Okay. If it is not contain the first user, put first user. U1 U1 is what? So I think all this, see, with the comment, I can give all this U1, G, I, J. I think all this variable name should be readable. Means
Mhm.
it should be based on the logic that we are writing, right? And that should have the proper naming convention, because all these are very very confusing. No one can understand this U1, G, J, all these
Yeah.
things.
Yeah. So
Meaningful readable name, yeah. Okay. So let's go over. So I got the user group, then yeah, that user group is basically key of my global collection, which is hash map of string and hash set, right? So
mhm.
that user group will be the key, and hash set is the list of accounts, I would assume, right?
Mhm.
Hmm. Okay. So first user not contains key, first user.
I think what you can think of this section as is just like building up the graph.
Building up the graph, yeah, yeah. Building up the relationship between like person one against the three accounts, something like that, right?
Yeah, exactly.
Mm-hmm.
That's all we're doing here.
Yeah, okay. So U1 not equal to first user, then it will get first user, add U1. get U1, add first user. Okay. So let's say this user group dot get J, which is giving you the U1. U1 is person one. I can assume that it is a person one.
Uh-huh.
Okay. So if my map not contains person one, it will put the person one with empty hash set, right? Then it will go and first user. First user is basically your that account name, right?
Mm-hmm.
So if that not contains account name, mm, 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 mm. So here I found something buggy. I don't know, but I think see if G contains key U1, not contains key U1, which is person. I'm just considering like person one and three accounts. Okay, so the
Mm-hmm.
three account will be a part of your set hash set, which is the list, and that person one should be the key. Okay,
Okay.
so if that G don't contains that person one, it will put person one with empty list. That is fine. Then second if my G don't contains that first user means you are actually the account name, correct?
Right.
So why we are putting that as a account name as a key? Because here in the first if we are putting key as our person one, which is group name.
Mm.
Mm, okay.
So I think what this maybe we can like think about it this way,
Yeah,
right?
yeah.
Like you have person one who are Baz. Okay, so we have these elements in here.
Mm-hmm.
Now, what you're doing is you're saying that up here, this user group, you're going to get I. So you're
Foo
going to get
has
this whole
basically
group.
like let's say Foo has three accounts underneath, right?
No, no. Well, okay. So person one has foo bar and
Okay,
Baz,
okay, okay, okay.
right? And then
Mm.
so now first user equals foo, and then the U1 is going to be user group dot get J. So J is going to be user group
So
dot size, user group. So use
U1, let's say U1 is equal to foo, right? No?
U1 is also initially going to be equal to foo.
Oh, yeah.
Right? So G is not going to contain U1 yet, right?
Correct,
Nothing,
correct, correct.
nothing
That
is in
is
there,
fine. So we have
right? So
added the list for the foo.
yeah, G is going to have foo, which is just going to be an empty hash
Empty
set,
list, correct, correct.
right?
Mm-hmm.
Now, next, you're going to see if G doesn't contain first user, and it does, so you're going to skip that. Now, if U1 does not equal first user, then you're going to, well, it does, so you're going to skip that, right? Now you're going to go to the next one, and you're going to say, okay, now U1 is going to be bar,
Bar.
and G doesn't contain bar, so we're going to say G is now going to have bar and as an empty
Empty
list.
list, correct.
After that contains first user. Well, G doesn't contain, uh, G does contain first user,
Mm.
right? So we're gonna skip that. Uh, yeah, G does contain first user, so we're gonna skip that. And then if these two don't match, they don't match anymore, right? Because U1 is foo and first user is bar, or the other way around, sorry. So first user, which is foo, gets bar in it, and bar, which is this is the U1 gets foo in it,
Mm.
right? And then now U1 is going to be Baz. So let's see, U1 is Baz, and so we're gonna put Baz in here because Baz is not in G, doesn't contain G, so we're gonna put it in a new hash set string. Now it does contain first user, so like foo, it does contain foo, so we're
Mm-hmm.
gonna go in
Correct,
there.
correct. Mm.
Now U1 and uh, Baz and foo are not the same. So we're going to put in foo, Baz, and in Baz, we're going to put foo, right? So after the first iteration of all this,
Iteration, okay.
this is what we're going to have at the end.
Mm. But they are all like okay, got it. So they are all like persons basically, not account so far. It's just a person.
These are accounts,
These are
but yeah,
account, okay.
like these are accounts right here, right? But these are accounts that we know belong to one person.
Hello? Okay,
Hello? Can
okay.
you hear me?
So foo bar and bars is accounts we are referring, right? For one
Yeah,
person.
yeah.
Okay, okay.
And then this is the person that we know that these accounts belong to.
Person one, okay.
Yeah.
So where is person one in that? Like we are not counting as a person one as a key anywhere.
Uh, we're not counting person one in this code. Yeah, we're not counting person one directly.
Okay.
We're just looking at for the relationships.
Further
But
relationship.
again,
Okay.
right,
Okay.
remember, this is some code that your report has submitted, right? And
Mm-hmm.
we want to um, see, does this make sense?
Okay. Okay.
Right. So what I was saying here is that what we're doing over here is just building the graph, right? And this is what the graph
Mm-hmm. Okay.
looks like,
Okay. Okay.
right? And then the actual algorithm happens down here.
Okay. Okay. Okay.
So
Let's
let's
go over that.
let's let's talk about what
Yeah.
algorithm are they using, and is it efficient?
Okay. Let's talk about that. Build graph starting traversal. Okay. Hash set. And get key set username and v dot contains username equal to false. Found new group helper username gv return counter. Okay. Helper. What helper is doing? Username gv uh, and v dot add in. So here this particular algorithm what it is doing is basically taking the entire key set and iterating over that and checking if username is contains uh, equal to false. It means not contains basically, right?
Mm-hmm. Mm-hmm.
Then increasing the counter
Mm-hmm.
and putting that into graph structure again, right? Is that I will go to helper, but it is
Yeah.
doing something in the helper method, and if not contains, then only it is increasing the counter and then returning the counter, right?
Right.
Found new group starting with username that okay. Let me check the helper what it is doing. V dot add. What is V? Okay. Do you want me to focus on this particular logic? That
Yeah,
for
yeah, yeah. This is
okay.
this is I think the main, right? Like we're trying to figure out, someone
Mm-hmm.
posted this for review, and we're
Mm-hmm.
trying to figure out what algorithm are they even using.
Mm-hmm. See, I think for finding out this username in the hash set, I think this is fine because it is one like big O of one complexity. So instead of
Mhm.
equal to false, we can have like not equal to like uh, not contains basically for better readability. If it not contains, yeah,
Mhm. Yeah, makes sense.
and then counter, yeah, counter plus plus also can work instead of counter equal to counter plus one, but that's okay. That will not. Mm. helper return counter. Yeah. So, I think that algorithm in terms of like complexity, it is fine. I don't see any issues. Okay.
Okay.
Uh, let's let's go back. What is this helper is doing? Can you help me understand this one?
Yeah.
Uh,
So what we're doing here is after we built up the graph,
hmm.
these are all of the, I guess, individual node names.
Mm-hmm.
And here we go through all the different usernames right now. So the graph, did I do that? No, I didn't. Okay, good. So the graph, right, it goes to foo and then bar and baz. And then from bar, it goes back to foo. And then baz, it goes back to foo, right? So you can kind of think of this as like an undirected graph of,
Mm-hmm.
node relationships, username relationships. And so
Mm-hmm.
when it goes through this this loop over here,
Mm.
uh, it it says, okay, well, if V, you can kind of think of that as like visited, right? This is another one of your comments that like you could
Yeah,
have that
visited.
as a
Mm-hmm.
better name instead of just V. But you like these are all this is the hash set of all the nodes that you've already visited. So when if you have already visited, if you have not visited this node yet, then increase your count of users,
Okay. Okay.
and
If we are visited,
run.
then skip that. Is right?
Yeah, exactly. And then run helper, which is effectively just DFS on that node, um, on that subtree.
Mm-hmm.
Right. So now when you run DFS, right, the first thing you do is you add that, okay, I visited this node, so that if you ever come like in that search of that subtree, if there's a cycle and you come back to that node again, you end your DFS because you don't keep going in cycles, right? You're just infinite loop then. Um, and so now you go through all the different neighbors, right? So if you're at foo, you go in bar and baz, and for each of those neighbors, you also call helper. Um, and then you just go all the way down, basically do
And figure out
DFS.
right how many of like basically visited or not visited, like kind of marking them.
Yeah, exactly.
Okay.
So I feel like we should talk a little bit about the algorithm, right? Because DFS may not be the best approach here,
Mm-hmm.
right? Like the time complexity, you know, well, first of all, when you have DFS, you have to explicitly build out that adjacency list that we were looking at before, right? When it was building out
Mm-hmm.
the graph.
Correct. Correct.
Each user group has k usernames, and so we have to create k squared edges, right? And if all usernames across all persons are linked potentially, right? Like you just have one
Mm-hmm.
user, it can
Mm-hmm.
be like a very significantly uh, expensive operation to construct the graph.
Correct. Correct. Correct.
And okay, fine, like put aside the issue of construction, right? But
Mm-hmm.
now you have DFS, which we're using a recursive DFS, right? Not even managing your own stack. But even if you were managing your own stack, right, it has overhead in terms of the function call stack depth, memory usage, right?
Correct.
So
Correct. Correct.
DFS has a problem there. Um, and then time complexity also with DFS, you have
I think it is n factorial for DFS. No, I think it will
uh,
increase, right? As you add the nodes.
yeah, it's not n factorial. Let me see. Yeah, I'm
Because
going
you're
wrong.
iterating over like each and every node.
It's Yeah, you're going to hit every node plus all the edges that you have.
Exactly, right? So
So you're going to have at least O of V or O of N plus the edges that you have to visit every time. So, assuming
so
that
it
there's one
it is
edge.
exponentially increase with the number of nodes that you are adding, right?
No, it won't exponent. It's going to
No,
linearly increase
linearly,
with
okay.
the number of nodes and edges. Um,
Because it is undirected graph. So from every node you are going to every other node, right? upwards, downwards.
Yes. And yeah, you might be coming back. Yeah, exactly. Right. Like, so from when you go to foo, you go to bar, you might come back from
Exactly.
bar
So that is what
to foo.
exponential increase, I think,
Uh,
with the node addition.
exponential is when you do something for the entire input set on every element of the input,
Okay.
right? N squared or n to the third or whatever, right? Like that's
Mm-hmm.
here you're going to go back, but you also have a check to make sure that, I have not I have visited it. I have not visited it yet, right? So even yes, you will go back, but the DFS will end. It won't
Okay. Okay.
continue going,
Mm-hmm.
right?
Yeah, I think
So,
let's go try to improve that, right? That is what your point is basically, how we can improve this, right?
yeah. So yeah, I think we talked a little bit about how DFS may not be the best algorithm here.
Mm-hmm.
If we go to the better code uh, tab, right? You'll see in that one there is better code. It's the same algorithm, right? We have an adjacency list, building the graph, uh, and figuring out what the different unique users are. We have DFS, all the visited nodes. This would be the better version of um, this code,
Mm-hmm.
right? And so now let's try to improve the DFS algorithm, right? Like we say that, okay, we don't like, I mean, DFS, it'll work, right? It's not a problem. Your time complexity is O of n, and your space complexity is potentially n squared. Not that great, right?
Not that
And
great, correct.
um, in any search problem, when you search through things, if you have to do O of n, that means you search through every.
Every single node.
Yeah, that's like the worst search algorithm, right?
That's the worst.
Like
That's the worst.
you've not done anything clever. So how can we do that? How can we do better than that? Like if someone, okay, let's say that your report, originally submitted the bad code, and then someone else on your team kind of didn't realize that your the algorithm was bad. They helped them get to this level of code, right? And now you looked at this. How would you look at this and then say, like, okay, what should we do instead?
Hmm. Yeah. Just give me a moment. I'm just.
Mhm. Yeah, sure.
Will the code review have this much complexity
In like in an actual code review in on the job or in the interview?
in the interview?
I have no idea.
Okay.
It depends on the interviewer,
Because
how
at
much
least like
code
with the
they've
code
had.
that the schedule is only 45 minutes, right? So we have to
Yeah,
cover a lot of aspects, not just algorithm.
yeah. Well,
Yeah.
algorithm I think is the main thing
Yeah, yeah.
when you're looking at it, right? Like because
But see,
uh,
guideline that I have gone through, right? The guideline they have given for this code review round,
yeah.
they can mention that we can cover all other aspects, and lastly the algorithms. Algorithm is important, but we should not start with the algorithm first. We should go with the other aspects of code review, like as I mentioned, right? The comments of variable name, more
Yeah, like
readability,
helper functions.
modularization, right?
Yeah,
Separation of
yeah. Right.
concerns and all these things, and
Hmm.
then algorithm.
Okay.
But algorithm, yeah, is equally important.
Yeah. So if that's the case, then maybe we uh return to the bad code and
Mhm.
just continue adding different um, things about, like, oh, you can do it this better and stuff like that, right? Like if we go back to the bad code, here's a system.out.println that really
They should all replace with logger, right? Means
yeah,
we can use
exactly, right.
logger.
Yeah,
Yeah, yeah.
don't print out random stuff like that, or like a
Correct,
debug
correct,
thing.
correct, correct, correct.
um yeah,
But let's discuss on this DFS, how we can. I think this is also important aspects. Let's I think we discuss on that hygiene part, but let's
Mhm.
discuss on this one algorithm.
Okay.
Uh,
Yeah, I'm confident that you can look at some code and be like, okay, this code has some smells, and here's how we can maybe improve it, refactor it this way and stuff like that.
mhm,
But I think, tomorrow when you in your interview, if you really
mhm.
want to blow them out of the water, right, you want to look at all the different aspects of the code review. The best code reviewers, right, like they're not looking at um, like code style and stuff like that, right? Because you have formatters and linters and stuff like that that automatically run
Correct,
when
correct.
they,
Automatically is taken care by
yeah,
means IDEs, right? Most of the
yeah,
IDEs.
exactly, right. So like those are small little details about like how many spaces to use and tabs and stuff like that. That's already handled by the time that you've
Mhm.
posted the uh, code review, and those code style things have the team has agreed upon some code style so that people
Correct,
just
correct,
just
correct.
follow it. Don't argue about like don't waste time arguing about nonsense stuff like that. So the best code reviewers are looking at design more than the actual code, right? Like how do the pieces fit together, and is this designed well such that I will be able to maintain it going
Maintain it,
forward?
scale it, right?
Yeah,
Maintainability, scalability.
because like I think like roughly the half-life of code in some of these repositories is about 18 months, right? So like 18 months later, half of your code that you submit will be gone. And so there's constant refactoring, constant improvements, requirements change, etc. And so what's most important for me, if I'm like a tech lead or a manager or like I'm owner of a project, is that anything that gets submitted, I need to be able to willing to maintain it, because now once it gets submitted, it belongs to everybody.
Correct,
And
correct, correct.
um, I'm not going to pass something that I feel is not up to like
Mhm.
maintainable. I think you should say all that stuff in your interview tomorrow too.
Yeah, yeah, sure, definitely. I will cover that because see, separation of concerns is also part of that maintainability, right? You should not
Yeah,
put everything in one class or one module, right?
exactly,
Yeah.
exactly.
And as I mentioned, right, static. Try to avoid use the static because static is not good for like unit testing. I means you can have some utility classes that can be reused somewhere else and easy to testable, right? All
I
these
think you should
things.
mention why, right? Like, I agree that static may not be the best use, but why?
Yeah, I think. See, means when you write the unit test cases, we have to mock the instances, and mock can be instances and not classes, right? That we can easily do, and I think that is the one of the reason static are not good. And static is another thing is when you load the class, basically at that time static contents and everything gets loaded. It will be early, basically early loading instead of lazy loading, right?
Yeah, but it's a unit test. Who cares about performance, right? If it takes 1 millisecond longer, then whatever, it's fine,
Mm.
right?
Okay.
I
Okay.
think the real reason why static may not be the best choice in unit tests is because it
Mm.
can have side effects. Whenever you run a unit test, right, you want to have a blank slate, everything new.
Correct.
And with
Mhm.
static, maybe that static function stores something in a static variable. Now, every time that you call that static function, it's dependent on the value of a static variable that was used last time, right? And so if you run a unit test in a different
Oh,
order,
got it,
say,
got it. So misbehavior, chances of misbehavior
yeah,
can happen.
if yeah, exactly, you run the unit test now in a different order,
Mm,
and
mm.
suddenly they start failing for some weird reason, and individually the test doesn't fail, right? If you just run it by itself, it's
But
fine.
integration test can fail, right? Integration
Yeah,
individually.
if you run all of the tests together, now
Hmm.
suddenly everything is failing because it's not running in the same order that you expected it to.
I will read about this because this is a very important point that I should be aware of in detail. Why part actually?
Yeah, yeah. So in the interview, right, like whenever you mention anything, you should say
Have
why.
some backing about
Yeah,
why, right? Means okay. Yeah.
because when you don't, like the interviewer is going to notice that, and they're like, oh, why? Right? They're gonna ask you.
Correct. No, I understand that. I think it happens in all other interviews as well.
Yeah.
Okay, I think let's, with the interest of time, we can cover this algorithm. So here
Okay.
in this DFS, basically we have to correct this DFS algorithm, right? So
Yeah, like how can we make it
what
better?
what I understand, right, from this problem statement is, here from every node we are going in depth, right, until the depth of the DFS and marking that, do I visit it, right?
Mhm.
That is the algorithm is all about, right?
Yeah, right.
Okay. Mm, 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 mm. So we have to traverse to graph and figure out like what are all the duplicates things. I think that is our problem statement, correct?
Mhm.
And graph is undirected graph. Okay. Mm, 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 mm.
And I guess a hint would be that DFS is a traversal method, uh, and it uses the data structure, adjacency list data structure, or an
Mm,
adjacency matrix,
mm,
whatever you
mm,
choose.
mm.
Um, and clearly the data structure and algorithm don't work, right? And there's a very famous saying that, given the right data structure, the algorithm will present itself. So I think what you should focus on is the data structure. That, how are we storing this data such that we can quickly
Quickly figure out, right?
determine that.
Means
Yeah,
figure out, yeah. Okay.
yeah.
Mm, mm, mm. So I'm just putting my thoughts. Let's say, uh, see if you can, basically if you can index on your account number, right? Account, let's say, which is
Mhm,
POS Kanji, something like that, right? So if you
mhm,
if you can index on that, and if you can start adding the persons, basically number of persons that particular account is having, let's say that POS Kanji will have the person 1, 2, right? So
mhm,
then with that you can easily identify like these are the same person, and you can count that as only one, right? So instead of going from the person, we should start storing from the, let's say, account number. If that kind of algorithms, means if that kind of data structure we can maintain, we can easily find out that uh, the basically the persons having number of accounts, and the accounts will have the number of persons, and we can easily figure out, like I'm basically heading towards inverted index kind of approach, right? Inverted
mhm,
index.
mhm,
So that will, I think, will improvise this particular algorithm that you're talking about. So inverted index has been used by, if you are aware of, like Elasticsearch, right, to search out the document and all, right? So
mhm,
something of that sort I'm thinking. So POS Kanji will have the list of persons, let's say person one and person two, like list of
mhm.
persons. In that case, I will just count that as only one, not two.
Right. But what about the transitive nature? Uh, right? Because if you do the inverted index, sure, but
Mm.
like how can you also with that declare that are you on the first tab?
First step, problem
Yeah.
statement, right?
Yeah, problem
Okay.
description. So how
Yeah.
can you, because of POSCANGR,
Hmm.
FUMCON and Stointy fifth are also the same person.
Which one? Form Conan?
FUMCON and Stointy fifth. I think you can do this, right? Inverted index will actually probably work. But
Form
you'll have to do a
can,
little bit.
yeah.
You'll have to do a little more post processing.
Little post processing, yeah. Little more post processing will definitely required in that case, yeah. Uh, but yeah, post conjure problem will solve with that case, with that. Okay. But see here in this problem statement, you are saying that uh, person one and person two is fraud. That's what we want to detect, right?
Mm-hmm.
But person two
Well, I mean,
has
it doesn't know which one is fraud, but just they're the same people.
there's okay. So we should not consider that post conjure account in person two basically, right? That is what, right?
Well,
Or they can club. We can merge that basically.
yeah, all of these 6 accounts actually become one,
Actually become one. Okay. Just because of that
right?
post conjure is belongs to person two, we can identify that both person
Exactly.
one
Yeah.
and.
So like if you
Hmm.
were to do like a select count
Hmm.
star
Hmm.
on
Hmm.
the database of all the number of users, right?
Hmm.
You'd have
Hmm.
6.
Hmm.
But now
Hmm.
because of the analysis, you actually only have one.
Hmm. Hmm. Person. Okay. So with that inverted index, I think person one and person two. Mm, mm, mm. Yeah, post processing is required for inverted index, but that will work. Definitely, that will work. Let me think or the other thing. Any other better data structure, right? Let me think over that.
If you'd like to, I mean, I think inverted index is good enough. Um, because you have a username, and then as you traverse through, you can go to person one, and now you have like kind of the backwards graph with an inverted index. So you go person
Hmm.
one, person two, and uh, all of your in person one, person two accounts are become one essentially.
Become one, exactly. So from inverted index, you will figure out that, right? How like
Mhm.
let's say post conjure is there in 4-person account, right? Let's say person one, two, three, four all have post conjure. So I will get the list of that post conjure will have person one, two, three, four, and I will consider that all the accounts belonging to person one, two, three, four will be the one person only.
Yeah,
So we
exactly.
will figure out that. So post processing is definitely required, but I think that will definitely work in here.
Yeah. Yeah. I mean, and in a code review, you don't have to go and like implement that, right? But you can tell them like,
Yeah,
hey,
exactly. So just
DFS may not be the best approach. Maybe consider a different algorithm. Talk to them offline as well. Like, hey, I just thought,
mm.
like,
Yeah, inverted index. Maybe I
yeah,
know, right? This is how it will work, and this is more efficient. Something like that sort, right?
yeah, yeah,
I think
yeah.
that will work. Yeah. Okay.
I think tomorrow they're also going to be looking at how you comment, right? Like, you don't necessarily want to tell them what to do, but kind of lead them to the right answer, like by asking questions and making them think about it,
Mm-hmm.
right? They're
Yeah.
not,
Yeah.
yeah,
I think right solution rather than right solution approach is very important, right? How we
yeah,
take the approach, basically the
yeah,
holistic approach, like as
yeah.
you mentioned, right? Maintainability, scalability, then why part, right? Why not static?
Hmm.
Why and how part, right? I think that is important. Yeah.
Yeah. Okay. What do you think? Do you feel a little bit better?
Yeah. I think it is a better use case, but I took time to understand that algorithm. Uh,
Yeah, I mean that's okay. I think you know you can lean on the interviewer for that. Kind of go back and
mhm,
forth between the interviewer, right? Like, but
mhm,
like you said, they're not looking for the algorithm as much based on the guidance that they gave you,
mhm.
as like the actual code implementation and things like that. I guess
Yeah,
there's some
actual code implementation and like that the concept you mentioned, right? Maintainability, scalability, separation
yeah.
of concerns, right? And
Hmm.
more of a like readability, like naming conventions, basically. That will be very important. Then algorithm is definitely if it is very bad algorithm, then we have to figure
Yeah,
out any edge cases that is going to fail in the logic, right? So that we have
right. Whether
to
they've added tests or
valid test
all that stuff,
cases or
right? Yeah,
valid basically if there is any for loop which is going out of the range, right? Something of that sort.
yeah, yeah. I would like. I mean, this is important, right? But like again, code reviews are not to find bugs. Um, I mean, maybe this is part of philosophy also, right? But I think code reviews are more about the bigger picture design issues. Bugs are for unit tests, right? You have unit
Correct,
tests to
correct,
find
correct,
bugs.
correct, correct, correct.
You're not A code reviewer is not expected to like go through a fine tooth comb, like, oh, this is working and stuff like that. I mean, you can, that's great if you do, right? But as a lead,
Mm.
with the role that you're interviewing for, right? You're thinking about bigger picture
Bigger
things.
picture, rather than like stuck on one particular small problem. Yeah,
Yeah.
yeah, yeah. But how you like this inverted index?
Yeah, I think it'll work.
Okay. Is there any better solution you have?
If you go to the best code,
Mm.
I put up some code which uses a data structure called union find, sometimes also called disjoint set data
Disjoint set,
structure.
okay.
What it does is it creates it tries to find the number of connected components in a graph by assigning each node like a component number, and then as another node joins a particular component, if that node and another node in that component matches, like overlaps with another node in another component, all the component numbers become the same. So they all kind of join the same component. And then after you do that, all you have to do is count the number of unique components inside your disjoint set. And then that's the number of users that you have.
Okay.
Yeah.
Disjoint set, yeah, okay.
But again, I don't know, like, if that's what they expect you to really talk about. But that's the way that I would solve the problem. You can take a look at the code if you like.
Yeah, if you can, yeah, you already shared with me. I will take a look offline.
Yeah, yeah,
Yeah,
sounds good.
yeah, yeah.
Um,
All right, I think, yeah, that's anything else you want to like give me the some hints? I think we
I think
covered pretty
just,
much, right?
yeah, but like just be confident, focus on, again, maintainability, scalability, right? We want to have a good algorithm, a good like a professional level of code, right? Like, this is going to go into the repository.
Correct, correct, correct.
We are all going to be owners of the code now. Now I can't say, oh, like, John wrote the code, so go ask him, right? Like, once it's merged, everybody owns it. And so you're only going to approve it if you are comfortable maintaining it going forward. Like, let's say the author just suddenly leaves the company tomorrow for some reason. Now you have to maintain it. Are you
Correct,
comfortable
correct.
doing
Are you
that?
correct? Exactly. Right, that mentality, I think we should have that mentality.
Yeah. So, comments based on that, like making sure that the code is up to that par, using all of the correct like libraries, right? You don't want to go and re-implement something worse, especially, in Google they use Abseal a lot. And so, if Abseal has something, why are you doing it yourself? Just go use Abseal. If there's a bug, now you only have one place to fix it instead of all the
Correct,
different
correct, correct,
places that
correct.
you've re-implemented it. And
So
those
FCL
kind
is
of
what?
things are,
FCL is common library kind of?
yeah, it's a common, like, it's like Guava, I guess, for C++.
Goa, Goa. Mm-hmm.
Yeah. So, uh,
Even for Java, it is Goa library only.
yeah. So,
Mm.
like, for Java, there's Guava, but for C++,
Mm.
Google's
It's
Abseal.
FCL. Okay, okay, okay.
And so, especially for large companies where you have like hundreds of thousands or tens of thousands of projects going on at the same time,
Mm.
right? You
Mm.
don't want, you're naturally going to have code duplication,
Correct.
and people will not, because you don't have visibility into, like, even your sister team's code, you know, much less someone completely far away in your organization. And so you don't want people to go and like suddenly implement string search badly, right?
Correct,
Like,
correct.
just use the library because we can then improve it, and then everybody benefits from the improvement.
Benefits from them, right? It is one
Yeah,
place change and benefits everywhere. Yeah.
exactly. Yeah.
No, I think
So
that makes
focus on
sense.
those types of comments. I think that will help. But
I think I
yeah, I wish
covered
you all
that
the.
in my
Hmm?
comments. I covered that
Yeah.
while you are checking the null and all, right? So
Yeah,
Goa, I think is yeah.
yeah.
Thanks for your
Um,
time for us. I think
yeah,
it,
of
it
course.
is interesting and helpful session for me. At least, yeah, algorithm was a bit complex. I am hoping it will not be the case
Yeah,
in real interview.
yeah. All the best.
Thank
I
you.
wish you all the best. Hopefully it
Thank you.
goes well. And this is your last interview, so hopefully you get a good result fairly soon.
Thanks. Thanks.
Google can sometimes take their time. So, just be aware of that.
Yeah.
They, yeah. But cool. All the best.
Yeah. Thank you.
Take
Thanks for
care.
your time. Thank you. Take care. Bye.
Bye.